Hello everyone and welcome. I am Pushpak Pandit and you are watching me on my YouTube channel Being Bookish. So today I am going to start trigonometric ratios chapter. If you are in class 9 then you must have got this chapter trigonometric ratios. One thing before I start, that if you are in class 9th or 10th of any board Icse or Cbse, this video is equivalent to all of them because trigonometric formulas are important even if you are in class 11th or 12th. Okay, we make use of each and every formula in any class. So if you are in any class, doesn't matter, continue in this video. So basically in this video I am going to give you introduction, okay, what is trigonometry, and the second thing which is the very much required thing is about discussing all the formulas which are there in this chapter. So the first thing is that many of us including me are afraid of trigonometric chapter. Means what happens, many of us talk about trigonometric as something which is very big thing in maths, but believe me, I also got afraid in the beginning, but afterwards I fell in love with trigonometric chapter. The first thing is that you should remember all the formulas and that's it. I will show you that how you can solve these questions which are from trigonometric chapter easily, and you will fall in love with trigonometric chapter. It is a very interesting chapter. So let's start. Now starting with the first thing, what is the meaning of the word trigonometric? Here is it. If I break this word into three parts, we will get tri, gon and metric. What is the meaning of these words? It is quite clear. Tri means 3, gon means side and metric means measurement. So basically trigonometric is what? Measurement of 3 sides. And answer me this question. What is the shape which we can obtain by the use of 3 sides? What is the shape which we can make using 3 sides? Obviously a triangle. So basically trigonometric is the study of relationships between the sides and also angles of a triangle. Okay, the definition is quite clear that in this chapter trigonometric we are going to see a relationship between the sides and angles of a triangle. So if you have understood the definition, then answer me one simple question. The definition is that trigonometric is the relationship between the angles and sides of a triangle. The question is that which type of triangle is it talking about? Which type of triangle is it really talking about? Remember this, okay, in trigonometric we make use of a right angled triangle. Which type of triangle? Right angled triangle. The second question would be what? That what is a right angled triangle? It's very easy. A triangle which contain one angle as 90 degrees. A triangle which contain one angle as 90 degree is considered as a right angled triangle. Okay, moving ahead, we have been given the chapter name as trigonometric ratio. So definitely we are going to take some ratio. The question is that what kind of ratio? The answer is that the ratio of some sides, of a triangle. But before that, I want that you should know that what are the various names in a right angled triangle. If you have learnt Pythagoras theorem chapter, then I think you are knowing what are the different names. But if you have not learnt, kindly see. See, this is called hypotenuse. This is called base and this is called perpendicular. Or it is also known as what? Height. It is also known as height, but it would be better to remember it as a perpendicular. Okay, so these are the various names in a right angle triangle. Okay, the trick to remember all these is that this is 90 degree and opposite to this 90 degree, which is the side? This is the side. Okay, opposite to this 90 degree, this is the side, and the side which correspond opposite to this 90 degree is called hypotenuse. And one special feature of this hypotenuse is that it is the longest side of this triangle. Okay, it is the longest side of this triangle. Talking about perpendicular, a line which makes 90 degree with the base is called perpendicular. A line which makes 90 degrees with the base is called a perpendicular, and it is also known as height. Why? Because it is the height of the triangle. Okay, you can clearly see. If I ask you what is the height of the triangle, you would obviously look at this and say this is the height of the triangle, and obviously this is the base. But it is very crucial to know the difference between a base and a perpendicular. Yes, you got it. Okay, it is very crucial to know what is the base and what is the perpendicular, because I know that you are often going to confuse what is the base and the perpendicular. See, what is the base? A base is something which contains one acute angle and also a 90 degree. Kindly see here, a base is something which has both an angle plus a 90 degree. This angle is acute angle. Acute angle is something which is less than 90 degree. So a side which contains one angle and also 90 degree will be the base, and the left part would be perpendicular, and hypotenuse can easily be seen because it is opposite to the 90 degree. Okay, so now let's see the various ratios which are involved in this chapter. First of all, I have denoted P as perpendicular, B as base, and H for not height but hypotenuse. Remember it, H is for hypotenuse, B is for base, and P is for perpendicular. Okay, the first ratio is sine theta. So here from now the chapter has started, so start noting all the points. Okay, don't get afraid of what is sine theta and all like. Okay, what is sine theta? Remember, sine theta is nothing but it is the ratio of perpendicular and hypotenuse of this triangle. Okay, so perpendicular divided by hypotenuse will give us sine of theta. Okay, the next thing comes is cos theta. Cos theta is the ratio of base and hypotenuse of this triangle. Cos theta is the ratio of base and hypotenuse of the triangle. So we will write cos theta as base upon hypotenuse. The next comes is tan of theta. So tan of theta is the ratio of perpendicular and base of this triangle. Perpendicular divided by base of this triangle. Okay, so keep a note of all these points. These are going to be very helpful and very crucial to solve the questions of this chapter. So sin theta is perpendicular by hypotenuse, cos theta is base upon hypotenuse, and tan theta is perpendicular divided by base. The first thing is that you should learn the first three. Okay, all the last three will get remembered easily, but in the beginning you should learn the first three: sine, cos, and tan. That sine is perpendicular hypotenuse, cos is base upon hypotenuse, and tan is perpendicular divided base. Kindly learn it. Now learn it. Pause the video and learn it. Okay. So if you have learned the first three ratios, you are definitely going to enjoy the rest three, because they are very easy and very similar. See, the next three ratios are cosecant theta. Okay, cosecant theta or cosec theta. What is cosec theta? It is nothing but the reciprocal of sin theta. It is nothing but the reciprocal of sin theta. So if sin theta is P upon H, means perpendicular upon hypotenuse, cosecant theta will be hypotenuse divided by perpendicular. And similarly, the reciprocal of cosecant theta is secant theta or sec theta, which is just opposite or reciprocal of cosecant theta. Means if it is base upon hypotenuse, it will be hypotenuse divided by base. And similarly, you have now made it that there is going to be reciprocal of tan theta, whose name is cot theta. So cot theta is equals to base upon perpendicular, and that's it. Okay, this is going to be very easy if you learn in this kind of manner. Okay, you can definitely take it as a trick. So sin theta, cos theta, and tan theta are the main roles, and cosecant theta, secant theta, and cot theta, these are just the opposite of these three. Okay, so learn in this manner that sine cos tan. Okay, opposite of sine is cosec, opposite of cos is secant, and opposite of tan is cot theta. So note all these points and then I will move ahead. Okay, kindly note it. Now the next thing comes is reciprocal relation. What is this relation? Reciprocal means opposite. The first thing is that sine theta is equals to 1 upon cosecant theta. This is the first formula, that sine theta is equals to 1 by cosec theta. As seen in the previous or the last minute, that you have seen that opposite to sine it was cosec. So we can definitely write as sine is equals to 1 by cosec. If you do not consider that this is true, then let me give the proof also. What was cosecant theta? I hope that you remember it. It is h upon p. It is h upon p, and this is equals to p upon h, means perpendicular hypotenuse, which is exactly equal to sine theta. So sine theta can be written as 1 upon cosec theta, and similarly cos theta can be written as 1 upon secant theta. Okay, and the third thing is that tan theta is equals to 1 upon cot theta. Okay, so sine theta can be written as 1 upon cosec theta, cos theta can be written as 1 upon sec theta, and tan theta can be written as 1 upon cot theta. But wait, we can also make some more formula using this only. Suppose I transfer this cosec this side and transfer this sine to this side. What I am going to get? I am going to get that cosecant theta is equals to 1 by sine theta. Yes or not? I am definitely going to get sine theta, means cosecant theta went here and sine theta came here. So cosecant theta is equals to 1 upon sine theta, and similarly I can also write that sec theta is equals to 1 upon cos theta. And in the similar way I can definitely write that cot theta is equals to 1 upon tan of theta. Okay, so these are the 3, 4, 5 and 6 more formulas in this chapter. Okay, so we have lots and lots of formulas in this chapter, and this is just the beginning. You call it no, that this is a trailer, so it is like a trailer. Okay, so note all these formulas, it is going to be very helpful. Now it's time for another very important relations. Okay, see here. What if I multiply sine theta into cosecant theta? What am I going to get here? Means if I am going to multiply sine theta into cosec theta, what is the answer which I am going to get? The answer is 1. How? See here. I can definitely write the cosecant theta as 1 upon sine theta. Just now I have told you that cosecant theta is equals to 1 upon sine theta. So this and this will get cancelled, and hence the value is 1. So sine theta into cosecant theta is equals to 1, and similarly cos theta into sec theta is going to be 1, and I think you have guessed the third thing, that tan of theta into cot of theta is also going to give us 1. So this is the another set of formulas here. I don't think that these formulas are very hard. Okay, just understand it as I am trying to say you, and it will be very helpful and very easy. Sine into cosec is 1, cos into secant is 1, and tan into cot is 1. Okay, now see another important formula. Can I write tan theta is equals to sine theta upon cos theta? Okay, the question is that can I write tan theta is equals to sine upon cos theta? Obviously yes, the formula is correct, but can you think that how it has been derived? See its derivation. Sine theta is equals to perpendicular upon hypotenuse, and cos theta is equals to what? Base upon hypotenuse. Yes or no? So sine theta is equals to perpendicular upon hypotenuse divided by base upon hypotenuse, which is cos theta. Now calculating it, what we are going to get? H and H got cancelled, and perpendicular upon base, which is nothing but tan of theta. So by this derivation you can see that tan of theta is equals to sine upon cos. Tan theta is equals to sine theta divided by cos theta. And in the similar manner we can write the next set of formulas, that cot of theta is equals to cos of theta divided by sine of theta. So these are the next two formulas which you need to make a note in your copy, that tan theta is equals to sine upon cos. One I have proved that how it came, and another is cot theta is equals to cos theta divided by sine theta. Now this is the last relation for this chapter only. Okay, so this is the last relation or the formulas required for this chapter. The formulas are also known as square relations. The formula is also known as square relation. Okay, so there are three formulas, but the first one is this, and I am going to prove it, that sine square theta plus cos square theta is equals to 1. This is the formula which you need to learn. See how it came. First of all, sine square theta also means sine theta to the whole square, and cos, let me take the LHS part. Okay, I have took the LHS part. So sine square theta can be written as sine theta to the whole square, and cos square theta can be written as cos theta to the whole square. Now tell me, sine theta is what? Perpendicular upon hypotenuse. So p by h whole square plus base upon hypotenuse to the whole square. So it is what? P square by h square plus b square upon h square. Taking h square as common means the LCM. What we are going to get? P square plus p square. P square plus b square. Now an important thing, if you know a Pythagoras theorem, you also know that h square is equals to what? P square plus b square. Means p square plus b square can be written as h square. So put this thing here. P square plus b square can be written as h square and divided by h square. So what we got? 1. So sine square theta plus cos square theta is equals to 1. You definitely need to only learn this. You don't need to derive. But the thing is that you are at the beginning level, so you should know how it came. The second formula is what? The second formula is that secant square theta minus tan square theta is equals to 1. Means I have learnt in the manner that put everything equals to 1. Okay, in the book it has been written as like what? 1 plus tan square theta is equals to secant square theta. So you can definitely see that if I transfer the tan square theta this side, I am going to get this only. So I remembered it like this. If you want to remember in any other manner, you can definitely go for it. The third formula and the last formula for this chapter is cosecant square theta, means cosec square theta minus cot square theta is equals to 1. Okay, but if you want to prove, then you can definitely approach using this method, and you can get that this is obviously equals to 1. Okay, so kindly note all these formulas. So we are done with all the formulas which are there particularly in this chapter. I have discussed and explained few of the formulas which were there in this chapter. Okay, so that's it for today, and in the next video I would be coming up that how you can solve the questions which are in this chapter. I know that most of you might be having trouble in solving the questions of trigonometric ratio chapter. Don't worry, in the next video I would be there. Okay, thank you.